Alright guys, today we're looking at more radicals as exponents, but now we're going to be looking at some operations that require us to be able to convert into exponential form. We've got two main ways of doing this. First off, if the bases are the same, we can use our regular exponent rules. That's going to be the main way that we're going to go through and do this. Second off, if we don't have the same base, we're going to need to try and get the same exponent. If we get the same exponent, we can just perform regular operations on the bases while keeping the same exponent. So let's go ahead and take a look at this. Alright, both of these are just like the first type because you see we've got the same base for both of these problems. So now I want to convert these into exponential form. So this will be x to the 1/3, and then this will be x to the 1/2. Now if you remember, I need to add my powers when I multiply the same base. But I can't add two fractions that don't have the same denominator. So I need to convert these to have the same denominator. The denominator would be 6, and so if I convert this first one will be 2/6, and the second one will be 3/6. Just like that. So we've got x to the 2/6 and x to the 3/6. Now I'm going to add my powers, and I'm going to get x to the 5/6. Just like that. Now I can convert this, and I want to convert this back to radical form. So if you remember from yesterday, we would have x to the 5 in parentheses and 1/6 on the outside. Or the same thing in radical form would give us the 6th root of x to the 5. Like that. That would be our answer right there. Now we want to do the same thing down here with these 7s. So we've got 7 to the power of 1/2 and then 7 to the power of 1/5. So I've got my two fractions there, and if you remember, division means we're going to subtract our fractions, but once again I've got to convert these to have the same base. The common denominator is going to be 10, so this first one will be 5/10. And the second one here will be 2/10. Now I want to subtract these, and I'm going to get 7 to the power of 3/10. Just like that. And like before, I want to split it up, and we're going to put it inside of our square root, or our root sign. So we have the 10th root of 7 to the 3rd power. Okay, we see here for the second problem, we've got two different bases. So we're going to have to try and get the same exponent for both of those. But let's start by looking at this first problem. Once again, we still have x for both of our bases. Let's start off just by converting these into exponent form. So I have x to the power of 1/3, and then x to the power of 1/2. I want to convert these so I have a common denominator. So that would be x to the power of 2/6 and then x to the power of 3 over 6. If I subtract 2 over 6 minus 3 over 6, that's going to give me negative 1/6. X to the negative 1/6. And if you remember our rules from yesterday, that's going to be 1 over the power of x to the 1/6. Which will be the same thing as 1 over the 6th root of x. We could rationalize this if we want to, but for right now we're just going to leave it like that. This second one here, we do need to convert into exponent form. And we see here, we now have two different bases and two different fractions. So we can either try and get the same base or the same fraction. And I think it's going to be easier to try and get the same fraction because you should notice that 1/4 is the same thing as 1/8 times by 2. So I can actually write this as 3 to the power of 2, like that, and then 1/8 on the outside. Basically, I started out by writing this as 3 to the power of 2 over 8. 3 to the power of 2 over 8, and then it got split up into this 2 and this 1/8 right there. So I started with 3 to the 1/4. I wrote it as 3 to the power of 2 over 8, because 2 over 8 is the same thing as 1 over 4. And then I split it up into these two numbers, the 2 and the 1/8. This over here is going to stay the same. So now let's simplify this right here. 3 to the 2nd power is 9. Well, now we end up with the same base. We also end up with the same power. So the two ways that I could do this is I could either multiply my bases and keep the same power, or I could just add my powers. So I'm just going to add my powers here, and this will be 9 to the power of 2 over 8. So if we're simplifying this, nine to the 2nd power and 1/8. Or we get the 8th root of 81, because we take 9 squared and that gives us 81.